Assalamualaikum and hi to everyone. Thank you for watching this video. So in this video, we will continue on the logical addressing or IP addressing in IP version 4. So block of addresses has been granted to a small organization. This one take from the previous video. Okay, this one is a block of address. So in every block of addresses, we have the first address and we have the last address. The first address, for example, here we have 32 and the last address we have 47, and total number of address or total RSPs for this block address is equal to 16. And you need to remember this one, the restriction that apply for the block of IP addresses. Address are contiguous, it must be continuous. If 32 and then the next one must be 33 and then the next 34, 35 until the end. The number of address must be power of 2. It cannot be 1. It cannot be it cannot be 6. It cannot be 5. It must be power of 2. The next one, the first address must be divisible by 16. So this is example. We have a block of addresses. The first address is 205.16.37.32 and then it followed by 205.16.37.33 and the last address is 205.16.37.47. So total number of addresses is equal to 16. You can do 47 minus 32, you get 15 plus 1. And you get 16 addresses. So this one is the general format of the IPv4. x.y.z.t/n and refer to the mask of the block of address. So the first address in a block of address can be found by setting the rightmost 32 minus n to 0. Okay, example here, a block of addresses is granted to a small organization. We know that one of the addresses is 205.16.37.39/28. Okay, we have a block of addresses. One of the address is 205.16.37.39/28. So /28 here is the mask of that address. So what is the first address in the block address? So the method that we use here, okay, the rightmost 32 minus n bit to 0. So change this IP address into the binary notation. So when you change, you will get this number. This one is the mask. So if we set 32 minus 28, so it's equal to 4. So 4 rightmost bit to 0, we will get, okay, 1, 2, 3, 4. Change this 4 rightmost into 0, so we will get this one. So you convert back into the decimal number, so you will get 205.16.37.32. So this IP address is the first IP address of this block of IP address. Okay, the next one, how to find the last address in the block of IP address. So the method is, we can set the rightmost 32 minus n bits to 1. Example here, based on the previous example, we use default mask as the 28. So 32 minus 28 is equal to 4. So the rightmost 4 we change to 1. Then change back to decimal number, you will get 205.16.37.47. So this is the last IP address and you can check back with this of block address. At the first address you will get 32, and last address you get 47. So this is how you can find the first of IP address of the block addresses and the last IP address of the block addresses. The number of addresses in the block can be found by using this formula, 2 power of 32 minus n. Okay, example here, find the number of addresses in example 19.6. Means refer to this address, number of addresses. You are given IP address 205.16.37.39/28. So based on this address, you need to find number of addresses or total space of address. So the value of n here is 28, which means that the number of address is 2 power of 32 minus 28. 28 is referred to n value, this one, based on this formula. So at the end you will get 2 power of 4 equal to 16. So total of addresses in a block of address is equal to 16. Another way to find the first address, the last address, and the number of addresses is to represent the mask as a 32 bits binary or 8-digit hexadecimal numbers. So in this particularly useful when we are writing a program to find these pieces of information. So in the previous example, /28 can be represented as 28 digit of 1 and followed by 0. So the first 28 is referred to the 1, and the rest, which is referred to 4 digit, is referred to the zeros. So find the first address, last address, and number of addresses. So the first address we can find by using the ANDing operation with the given mask. So ANDing here is done by bit by bit. So the result of ANDing, 2 bit is 1 if both bits are 1, and the result is 0 or 10 or 00. So we have the address. From the decimal, we change to the binary number, and then we have the mask, which refer to 28. So change into the binary, and then we do the ANDing process, ANDing operation. So 100, 100, 100, 100, 000, 010, 111, 010, 010, and do the same thing for the rest of binary digit. So at the end, you will get this value, and when you change back into the decimal, you will get the first IP address. Okay. To find the last IP address, you can use the ORing operation. So you get the IP address, change to the binary notation, and then the mask complement. Okay, the mask is 28, so find the complement of 28. So mask complement means 1 change to 0 and 0 change to 1, and then you do the ORing operation. So in ORing operation, 111, 111, 111, 011, 000, 101, 000, 000. Do the same thing for the rest of the bits. Then this will be your last IP address of your block of address. The number of address can be found by complementing the mask, interpreting it as a decimal number, and adding 1 to a bit. So your mask complement from 28 of 1 change to 0. So now we have 28 of 0 followed by 4 of 1. So this one, when you convert into decimal, it gives you 15. So 15 plus 1 equal to 16. So this one is the number of addresses in a block of address, or what we call as the address space of a block address. Okay, the next one is network configuration for block 205.16.37.32/28. So from this point, we know that this is one of the address in that block and the default mask is 28. Okay, the address in a block is normally not assigned to any device. It is used as the network address that represents the organization to the rest of the world. So first IP address inside a block of addresses is not assigned to any device, but that address is being used as the network address that represents the organization to the rest of the world. Means through the internet, just use that the first IP address as their unique identifier. So the net ID is specific, the host ID all zeros. So here we have class A, class B, and class C. Okay, this one is referred to the network address. And how they communicate from this one to this one to this one. Okay, this one is the hierarchy in the telephone network. We have the area code, we have the exchange office, and we have the subscriber. So basically, in organization like UITM, we have one phone numbers, and we use these phone numbers in order to interact with the outsider. However, every office have their own numbers. So we have the operator that can redirect you to a specific numbers, but we only have one number to be called in one time from the outsider to the organization. It is example. So we have the subscriber, and then we have the exchange office, and then we have the area code. So two level of hierarchy in IP address before. This part without the subnetting. So we have 28 bits, 4 bits here, 28 plus 4 bit equal to 32 bits. And then we have the network prefix, and we have the host address. So the first 3 byte is referred to the network prefix, and for the whole bits is referred to the host address. Each address in the block can be considered as a two-level hierarchical structure. So the leftmost and bit we call as the prefix. So this part defines the network, and the rightmost, which is 32 minus n, define the host. In the next part, we will continue on the IPv6 in the next video. So at this point, you should know how to identify the first address, the last address, and the number of addresses in a block of addresses given to you. Okay, basically, we have two methods. The first one, we can use the formula in order to identify the second numbers. Okay, the first formula, you use total numbers of IP size 32 minus with the mask of the address, and then in order to get the first address, you change the n rightmost to the 0. To get the last address, change the rightmost to the 1. If you want to use the binary conversion, you can find using the mask to ending and do ORing with the mask complement. This is the way on how you can identify the first address, the last address, and the total number of addresses. So see you next video. We'll discuss about the IP phishing. Thank you and Assalamualaikum.